Welcome to the last breakfast. Please enjoy the video.
You begin by committing to a high-pole, high-torque motor architecture, because that is the only way to get sustained low RPM without excessive reduction. Choose a large diameter rotor and many pole pairs. This increases torque per revolution. Once decided, size the stator stack and magnet strength around your target RPM and torque. Make sure to select thicker copper for lower coil resistance and stronger ND-Pb magnets to maintain flux. Start preparing lamination packs and magnet holders now so the build follows geometrically. You now perform the detailed middlework, the winding and stator assembly. Calculate turns per coil from the back EMF target and kV you need. More turns raise torque constant. Wind coils with steady tension and use lits or multiple parallel strands to reduce AC losses even at low frequency. Pack stator laminations tightly and maintain a uniform air gap. Small asymmetries will kill low-speed smoothness. Once coils are potted and cured, verify insulation, trim leads, and pre-balance the rotor assembly to avoid vibration at slow RPM. You complete assembly and move straight to commissioning. Install the rotor, verify axial end play and radial clearance, then perform a static balance. Use a slow-ramping current source or a motor controller set for low-frequency commutation to bring the motor up gently. Measure torque, current, and temperature during incremental runs to validate performance. If things go wrong, check air gap symmetry first. Uneven gaps cause cogging, then verify winding continuity, magnet polarity, and controller timing. Correcting those usually resolves low RPM problems.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.